Okay, good afternoon, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be presenting this afternoon will be a do-it-yourself uh, solar equipment which we could use in our homes during times of brownout. What I did, I bought my inverter here. I got a solar battery. I got a voltage regulator. When I needed to charge this battery here, I got my solar equipment on the first floor. So whenever the voltage of this one go below 12 volts, I must have to energize this one or charge this one because my inverter will not work if the voltage goes beyond that or below 12 volts. So what I did now, I plug in here a load. This is the alternating current output of this do-it-yourself solar inverter. Okay, and actually I assembled the power supply of my small radio. This is actually a 3 volt voltage regulator. It got some small transformer here, and this is actually the 3 volt voltage regulator because the voltage requirement for this transistor radio is 3 volts. So this now serves as my load to show you that the do-it-yourself inverter in which we needed this one just in case there is a brownout, we could use this one. The connection of the inverter and the battery is just straightforward. The plus and minus of the battery goes to the input of the voltage regulator, and the output of the voltage regulator goes to the inverter at the back here. This is the plus and minus terminals. The purpose of the voltage regulator is to regulate the voltage that goes to the inverter even with a not so high voltage battery. If there is a voltage regulator here, of course what will come out will be a regulated DC voltage that goes to the inverter, because this inverter got a sensor in which if the voltage go below or below 12 volts, it will try to ring a siren indicating that we should shut it off because it will not operate under the low voltage condition. It will operate, but to avoid the destroying of the inverter, we must have to shut it off. Okay? So right now, all the connections are made. The plus and minus of the battery goes to the input of the voltage regulator. Okay, and the output of the voltage regulator, okay, it goes to the inverter. So the one powering up the inverter is actually the output of the voltage regulator, and this regulator is powered up by this battery here. Because an inverter, as you know, it's a machine that converts direct current to alternating current. So this one here, the output of this one is a sine wave. This is the output terminal. This is the switch. So this one got a plug, and the output of this one is supposed to be 120 volts. Okay. If we try to operate this one now, the connections are all made. So I will just flip this one, and let's try to see if this do-it-yourself solar equipment will power up my load, in which that load is actually a voltage regulator with a radio load at the back. So I will now try to flip the switch. And it works. Okay, it works. Okay, so actually this do-it-yourself solar inverter plus this battery here, we could use this one in our homes, okay, as a standalone power supply, other than the voltage coming from the utility line going to our outlets. As long as this battery here is charged, we could bring out a 120 volts here to power up any load that requires 120 volts. Okay, one more time. I will try to flip the switch. And the radio works. Okay, the radio works. The radio works. So, this is the so-called do-it-yourself equipment or gadget that we could use here in our home. Good afternoon from Los Angeles. This is Professor David J. De Los